In this video, I'm going to do a couple problems on solving for dot products. So let's start with the first example. So we're asked to find the dot product of A and B if we're given this vector, A, and this vector, B. So how do we go about solving this? Well, we start by thinking about which definition we can use. So we have our two dot product definitions of our geometric or our component definition of where we add the products of our components. So like this and so forth for more dimensions. We also have our geometric definition, which is our magnitudes times the cosine of the angle between them. So we got to ask ourselves which one of these we can use. And in this case, we have to use our component definition because while we could solve for the magnitudes of these vectors, we don't have any information on an angle. So this one, the geometric definition, we can't use. But this one, we know all our components, so we can simply plug in the numbers. And so this would look like A dot B is equal to the x component of A times the x component of B plus the y component of A times the y component of B. And then the same thing for the z component. And if you plug that into your calculator, you get 68. And that is the value of the dot product for these two vectors. Now let's do question 2. And so I've drawn two vectors out here where you've got A and B, and you've got this angle with respect to x, and then the angle phi, which is the angle between the two vectors. And then we're given as well the magnitudes of both vectors. And we're asked to find the dot product using both of these definitions. So let's do that. Let's first look at what the easiest solution would be. So we have the magnitudes and we have the angle between the two vectors. And so what that means is we can just plug numbers straight into the geometric definition. So that's our easiest solution. So let's do that first. So we have 6 times 7, our magnitudes, and the cosine of phi, the angle between the two vectors, is 63. And what we get from that is our dot product is 19. That's rounded to the nearest integer. And that's our answer. So in most cases, we solve this problem now. We don't have to do anything else. But I think it's good practice to go through and do the other definition, solve it using this one. So let's do that. And to do that, we have to find the components of both of our vectors. So let's start with A. We know the magnitude, we know the angle, so we can use our cosine and sine functions to solve for the x and y components of A. So let's start with x. This is our adjacent, so the cosine is the x component over the magnitude, and therefore we get that ax is equal to the magnitude 6 times cosine of this angle now, the 20 degrees. Plug that in and you will get 5.6. Then for the y component, we just do the same thing, but use our sine function. And you should get 2.1. Now let's do b. So there are two ways you can do this, really. Two angles you could use, I should say. So we can go, you can use this angle, find that angle, or else we can use this angle. And I'm going to use the smaller angle here. So I'm going to call this that symbol, and we're going to use this right triangle here, where this is BY and BX. So what is this angle? Well, we can find a relation to solve for that angle, which is just that this whole quadrant is 90 degrees. And then we can subtract out the other two angles we have. So minus phi minus theta, which is just 90 minus 63 minus 20. And that is equal to 7 degrees. So the important thing to note here now is, with this being 7 degrees, this angle is with respect to the y-axis. And so the adjacent angle, or the adjacent side of the triangle, is the y component. And so we can't use cosine anymore to solve for our x. We would use sine to solve for the x, because the x component is on the opposite side from the angle. So now we have to switch it around. So sine of theta, actually this should be this one. Sine of that is equal to bx over the magnitude of b. So bx is equal to 7 magnitude of b sine of 7 degrees. And from that, we get that bx equals 0.85, which is this side up here. Then we do the same for by, is 7 cosine of 7 degrees. And so by is equal to 6.9. So now that we solve this, we have everything we need to write out our component definition of the dot product. So A dot B is equal to AX times BX plus AY times BY. And when you plug that all in, this will work out to 19. Now the value might be a little bit different because we rounded some numbers as we went. So if you keep all of your digits, it should be exactly the same as this. So if you see that discrepancy, it would be because of rounding as we went. So it's good in a way not to round as you go, but to round at the very end. But those are a couple examples on the dot product, and it shows, it's good to think about which definition you can use. Sometimes you can only use one in the case of this problem, but sometimes you can use both, and it's easier to use one over the other most times. So those are a couple examples. I'll do a more complicated example in the next video. Thank you for watching.